C++ was invented by Strostrup in 1983. It is one of the most prominent programming language in use today. It is a general purpose language that has support for multi-paradigm programming. It is object-oriented, procedural, imperative, functional, generic, type-safe, nominative, statically typed, and has support for templates and structured exception handling. One of the principal reason why C++ is successful is that it is a superset of C. So the code of C works 100% in C++. The latest version of C++ is version 11, that is C++ 11, and this was standardized in the year 2011. C++ is designed with a strong bias towards systems programming for use in embedded systems or operating system kernels with performance, efficiency and flexibility, and it helps us to incorporate good designs. C++ is used for development of various kinds of applications. It has been used to develop desktop applications like MS Office, OpenOffice, Adobe Reader, and many torrent software. It also has been used to develop .NET CLR, Java, JVM, have been developed using C++. Another area where C++ has been very successful is in development of browsers. All the major browsers that exist today like Opera, Firefox, IE, Chrome have been developed and are continually getting developed using C++. C++ is suitable for development of applications that are large in nature, that require scalability, that requires reusability. There are many examples that we can take where C++ has been used to develop applications which run in millions of lines of code. A good example over here is MS Office. Another reason that C++ is successful is that it is very widely used to develop system software and low-level software like device drivers, antivirus software, medical software, avionics software, and so on. Object-oriented programming is one of the cornerstones of C++. C++ was the first mainstream, popular, object-oriented programming language. Prior to C++, there were many O languages that existed, but none of those languages could achieve the popularity that C++ could achieve. So C++ allows us to do abstraction, and abstraction is the foundation on which problem modeling is done. And because of that, we can really challenge contemporary problems and futuristic problems with C++ because it allows us to perform abstraction. And because of this, applications that we develop are flexible, decoupled, and hence we can incorporate scalability and reusability in it. C++ is a compiled language in the sense that it is statically typed, and there are many implementations of C++ that exist like Microsoft, Intel, Free Software Foundation, and low-level virtual machine. So these are some of the examples where we find the C++ compiler. After completing this course, you would be able to understand and appreciate the strengths and weaknesses of C++. You will be able to write object-oriented programs. You will be able to explain and implement encapsulation, inheritance, polymorphism in writing C++ program, and specifically the high point of C++ programming is understanding the idea of polymorphism, and to be more so accurate, it is dynamic polymorphism. So this is something very important, and I urge all of you to pay special attention on polymorphism. You will also learn how to apply various kinds of keywords available within C++ to enhance the quality of the program, and certain kind of nuances and certain kind of abstractions that have to be implemented can be absorbed within our program by these keywords. A good example for this can be the static keyword, which allows us to have access of an element at class level. One of the key defining capabilities of C++ is multiple inheritance. Multiple inheritance can be a useful feature, but if not implemented correctly, can be a very disastrous element within a software. And this is because if we do not use multiple inheritance correctly, our applications are unscalable. As part of this course, you will understand how you can perform string operations. String operations play a very significant role in certain kind of software development. A good example of this is in the biotech domain, where heavy string manipulation is required. You will also learn and apply how you can develop reliable applications using structured exception handling. And specifically over here, you will understand and apply try, catch, and the throw keyword. And as part of this course, you will understand and implement templates and file input output. And most importantly of all, when we write any kind of program, to develop better skills as programmer, understanding debugging plays a crucial role. So you will also learn about how you can debug C++ programs using Visual Studio. Now, let us look at the structure of this course. This course has been divided into 6 modules, and each of these modules have their own significance, and the modules are arranged in an incrementing order in terms of the capabilities that the language C++ offers. In the first module, you will learn about the overview of C++, understand what is C++, define C++, and look at success of this language. Thereafter, you will also understand the various programming models that this language offers. And then we will also compare this language with C and Java and understand the limitations of C++ as well, which is very important. In module 2, you will learn about the basics of the C++ language. You will learn about how you can perform compilation, how linking happens, and how the program gets executed, how command line arguments can be captured, and the data types that are offered in the language. We'll also learn about the scene and cout object, and we'll also implement the various kinds of operators that are supported in C++. The module 3 is the most significant module of this course. And in this, I will introduce you to the crucial, the central, the most important, and the high point of C++, that is object-oriented programming. In this module, we will learn about encapsulation, data abstraction, data hiding, inheritance, and important keywords like the friend keyword, the static keyword, the inline keyword, and then we will see how polymorphism can be implemented, the static polymorphism, dynamic polymorphism, early binding, late binding, and then we'll also understand the central concept of virtual tables. And towards the end, we're going to see the benefits of multiple inheritance and the limitations of multiple inheritance. And all this we're going to learn by writing programs. The full course is a hands-on driven course, so there is a lot of importance and emphasis on code. After that, we'll take up module 4. The module 4 looks at 2 crucial aspects that are available in this language, that is string operations and structured exception handling. So in this module, I will help you to learn and understand the string class and its functions. It will also cover structured exception handling and how that can be implemented. And after that, we're going to look at how we can implement class and function templates, that is in module 5, and how we can perform debugging. And the last but not the least is the module 6. In this module, we're going to learn how we can work with files in C++. Thereafter, over here it is very important to know how this course has been arranged and how it can facilitate your learning. Over here, as part of this full course, there are many components that are there. That is, there are video lectures, there is reading material, there are quizzes, exercises, and a project. To get the maximum out of this course, you have to go through all of this in a linear fashion and apply all the important concepts so that your understanding of C++ enhances. Hope this was a constructive session for you. I wish you all the best for your future endeavors. Happy learning.